Good afternoon, class. We are looking at trigonometric functions. Here's the phase shift sinusoidal curve fitting. So we've covered graphs of sine and cosine, graphs of tangent, cotangent, cosecant, secant, and secant functions. And now PS, short for phase shift, more graphs. Phase shift sinusoidal curve fitting. So the objectives are we want to graph sinusoidal functions of the form A sine omega x minus phi plus b. We take the omega out. A sine omega times the parenthesis x minus phi over omega plus b. And the same thing for cosine, a cosine omega x minus phi plus b, and build sinusoidal models. Those are the objectives. Recall. How did we graph sine and cosine functions? There were different methods. The best course of action was to cut it into 4 arcs. So we would divide the period into 4 pieces from 0 to 2 pi, cut it into 4 pieces. We get pi over 2. So 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. And so for sine and cosine, we would find important parts. That means find 0, 0, pi 0, 2 pi 0 for the sine function as the x-intercepts, pi over 2, 1, comma, 3 pi over 2, negative 1 as the max and mean. We would do the same thing for cosine. The x-intercepts located at pi over 2, 3 pi over 2, 0. The max at 0, 1, as well as 2 pi 1, and the minimum at pi negative 1. We also know that sine is the same as cosine, has been shifted by pi over 2 to the right. So cosine of x minus pi over 2. And here's a sine omega x, where the period t is 2 pi over omega. So when we have a basic sine and cosine function, the period is 2 pi, the amplitude is 1. When we have a sine omega x or a cosine omega x, it changes the period to 2 pi over omega, and the amplitude is the absolute value of a. Other functions are here. We have the tangent looking like almost y equals x cubed, cotangent like minus x cubed. For secant and cosecant, when we want to graph secant, we graph cosine, and then that will help us find, flip it over, and we'll find secant. If we want to graph cosecant, first we graph sine. You can look at one period, a complete period, and then you can see the extension, and we can find the graph. So we have the information here. Remember, tangent is sine over cosine. That will help us see where we have the vertical asymptotes, the domain, range, and so forth. Cotangent is cosine over sine. Secant is 1 over cosine, and cosecant is 1 over sine. And that will give us all the information we need. You really don't have to memorize the formulas if you can figure out what's going on here. As an example, if you want to know where the x-intercepts happen for tangent, you set the numerator sine x equal to 0. And you have the answer, therefore n pi comma 0. If you want to know where the function is undefined, set cosine x equal to 0, which gives you 2n plus 1 times pi over 2, and that gives rise to vertical asymptotes, as well as giving you the domain all but those points. You can do the same thing with the rest of them. And now the phase shift and sinusoidal curving. graph sinusoidal functions of the form y equals a sine omega x minus phi. We are assuming a is positive, omega is positive, and phi is positive. So you factor the omega out. When you do that, I want you to pay attention to this part. When you factor the omega out, you get a sine omega parentheses x minus phi over omega, this part. And that's why the shift, the phase shift, this is moving to the right by this much, not phi over omega with the period of 2 pi over omega. So the amplitude is the absolute value of A. The period which was 2 pi, now you divide the 2 pi by the coefficient of x, omega, and therefore inside the parentheses next to x, whatever we have is the phase shift. If phi is less than 0, phase shift is to the left, and phi is positive, phase shift is to the right. That's the synopsis of graphing. So what are the steps? We will repeat the same type of step and find the key points as follows. Steps for graphing a sinusoidal function of the form y equals a sine omega x minus phi plus b, or y equals a cosine omega x minus phi plus b. Sometimes they put the b here, c here, and d here. So in case in some text, everybody, you may find the following: a sine of a bx plus c plus d. You may find it in this format. It doesn't matter. It's the concept that matters. Okay. All right. So how do we do that? Number one, determine the amplitude, which is absolute value of it, and the period, which is 2 pi omega. And when you do that, when you take the omega out, the phase shift becomes phi over omega. Please understand, when you take the omega out, as we showed in the previous page, let me just show you one more time here. So this one, for example, becomes a sine omega x minus phi over omega. That's why. Here's the phase shift. And then we divide the interval as before with the starting and the ending points of one cycle of the graph into 4 subintervals of the same length, 2 pi over omega divided by 4. And then because there is a phase shift, we start with this phase shift, and then we add this 2 pi over omega first, and that gives us 4 parts, and we divide this into 4 subintervals. Use the endpoints of these subintervals to obtain the 5 key points on the graph. Plot the 5 key points and connect them to obtain the graph of one cycle. Extend on each side to make it complete. Finally, if there is a b and it's not equal to 0, apply a vertical shift up or down. Let's look at these examples to what we do. We want to find the amplitude, period, phase shift, and graph. So first and foremost, it's important to take this 4 out. So we take the 4 out. Becomes minus 2 cosine of 4. This becomes x. This becomes pi over 4. Now, the amplitude doesn't change, absolute value of -2 or 2. The period doesn't change, but it helps us see it's 2 pi divided by this number, the coefficient of x divided by 4, which means pi over 2. So the period would be from 0 to pi over 2 if there is no phase shift. So this would be the period. A complete cycle, we're going to go from 0 to pi over 2 if we didn't have a phase shift. But according to this, the phase shift is pi over 4. So we are going to move this by pi over 4 to the right. So let's add pi over 4 to each end. When we do that, 0 becomes pi over 4, pi over 2 and pi over 4, they add up to 3 pi over 4, which means we don't start from 0, 0, but rather we start from pi over 4 and we go to 3 pi over 4, and that's a complete cycle. Now, we're going to cut the period because the distance, no matter what you do, this difference or this difference is still the same thing, pi over 2, which is the period. We're going to cut this into 4 parts, which makes it pi over 8. So divide this by 4, we get pi over 8. So this is a complete cycle. And we are going to cut this into 4 equal parts. For example, the first one becomes pi over 4, and then pi over 4 plus pi over 8. Just for the sake of argument, the very first one, pi over 4, the very first sub-interval. Everybody is pi over 4 and pi over 4 plus pi over 8. Now, of course, pi over 4 is 2 pi over 8, so this is 3 pi over 8. The next one, just as an example, starts from 3 pi over 8, and it ends up with 3 pi over 8 plus, again, the same thing, pi over 8, which means 3 pi over 4 and 4 pi over 8, 4 pi over 8, 4 pi over 8 is pi over 2. You keep on doing it 2 more times, and this is what you get. So let me make sure everybody understands what's happening. The first one is pi over 4. Add pi over 8, you get 3 pi over 8. Now add pi over 8, you get pi over 2. Add pi over 8, you get 5 pi over 8. And add pi over 4, you get 3 pi over 4. Meaning the first one is pi over 4 to 3 pi over 8. The second one is 3 pi over 8. My apologies, I think this was 8, and so is this one. 3 pi over 8 to pi over 2. Okay. And then the next one is from pi over 2 to 5 pi over 8. And the last one is 5 pi over 8 to 3 pi over 4. So those are the sub-intervals, everybody. Sub-intervals. So I hope everybody's clear. I'm going to recap. This is very simple. The amplitude is easy. You divide the 2 pi by 4, you get pi over 2. So a cycle would go from, a complete cycle go from 0 to pi over 2 if we didn't have a phase shift. Because we have a phase shift, we're going to go to the right by pi over 4. So we're going to add pi over 4 to both pieces. When we do that, this is going to be a complete cycle. Cutting it in 4 gives us pi over 8, and we make up the 4 sub-intervals. Now, we need to find the y-coordinate for each point. So pi over 4 as an example class. If I put pi over 4 here, this becomes 0. Cosine of 0, everybody knows. I'm going to calculate a couple of them, and then, so for pi over 4, I get y equals -2 cosine of 0. You should know cosine of 0 is 1. So the answer is -2. Okay. So what does that mean? That means I have the pair pi over 4 and -2. So just locate it here, pi over 4 negative 2. Let's go with the second one. The second one is 3 pi over 8. So if I put 3 pi over 8 here, and I subtract pi over 4, so let's just write it. So minus 2, so y is minus 2 cosine of 4. X is 3 pi over 8 minus pi over 4. Okay. Again, these are all common arcs. We can do this. So 3 pi over 8 minus 2 pi over 8. Right? This is pi over 8 times 4 makes it pi over 2. So it's negative 2 cosine of pi over 2. You should know it's 0. Therefore, the pair is 3 pi over 8 almost 0. Let me do this in our mind. The next one is pi over 2. If I put pi over 2 minus pi over 4, I get pi over 4. Okay. 4 times pi over 4 is pi. Cosine of pi is negative 1 times negative 2 is positive 2. I hope everybody can see that. One more time. Put the pi over 2 here. Pi over 2 minus pi over 4 is pi over 4. Times 4 is pi over 4. Okay. Times 4 is pi. And you get cosine of pi negative 1 times negative 2 is 2. So those are the pairs. I showed the work for this one. I showed the work for this one. And this one, again, just plug in pi over 2. You see that? The rest of them, these two, I'm going to leave it for you to verify we get those pairs. It's easy. So all you have to do, pi over 4, locate pi over 4, negative 2, locate 3 pi over 4, 0, and the rest of it. And it looks like that. Now you continue indefinitely on both sides. So again, first you plug those pairs. Then you connect them. It's a complete cycle. And now going from negative to positive infinity. Okay. Here's another one. We want to do the same thing, for example, to find amplitude, period, phase shift, and graph y equals 3 sine 2x minus pi. The very first thing, we take out the 2. When I factor out the 2, this becomes x, this becomes pi over 2. So 2 times x minus pi over 2. The reason you do that because you want to know the phase shift. So the amplitude is 3. T is 2 pi over omega, so 2 pi over 2, meaning pi. So if we didn't have any phase shift, we're going to go from 0 to pi, and that's a complete cycle. However, the phase shift is what? Negative pi over 2, that means to the right by pi over 2. So to the right by pi over 2, add pi over 2 to each end. So this becomes pi over 2, this becomes 3 pi over 2. So a complete cycle goes from pi over 2 to 3 pi over 2, everybody, okay? Let's cut the period t, which is pi, into 4 equal parts. Pi over 4. 4 equal parts. And we are going to cut this into 4 subintervals, which means the first one is pi over 2, add to it pi over 4. So just again, just the first one. So you see the first subinterval goes from pi over 2 to pi over 2 plus, let me just use it, plus pi over 4, which means pi over 2. To remember, pi over 2 is 2 pi over 4 to 3 pi over. The second one, 3 pi over 4 to 3 pi over 4, again, plus pi over 8, which means 3 pi over 4 to, I hope you realize, 3 pi over 4 is 3 pi over 4 plus pi over 4. Why did I put pi over 8 here? Pi over 4 is 4 pi over 4. 4 pi over 4 is pi. And we continue with the rest of them. So one more time. The endpoint for the first one is pi over 2. The next one, you add pi over 4, you get 3 pi over 4. That's what we got here. Now we add pi over 4, the next one is pi. So I got these two. Now add pi over 4, you get 5 pi over 4. Add pi over 4, you get 6 pi over 4, or 3 pi over 2. And so you write 1, 2. I wrote the first one for you here. I wrote the second one for you here. Now the third one starts with pi and ends with pi over 4. The next one starts with this. See, please note the following. This goes here. This goes here. This goes here, okay? And this one ends up being here. This one is the last one, okay? So you're cutting pi over 2 to 3 pi over 2 into 4 sub intervals. Okay, that's what you're doing. Now we are going to evaluate at every end point, meaning 1. We're going to evaluate it at pi over 2, 1. At 3 pi over 4, at pi, at 5 pi over 4, and finally at 3 pi over 2. For example, let's plug in pi over 2, and I'll show you. Let's start with, let's see, let's start with pi over 2. So y is equal to, if I put pi over 2, I get 3 sine 2 times pi over 2 minus pi over 2, which is 0. I get 3 sine 0, and we know sine of 0 is 0, and therefore the first pair has coordinates pi over 2, 0. That's the first pair. Let's do one more. Let's see, number 2. The next one is 3 pi over 4. So I want to put 3 pi over 4 here, okay? So I'm going to put 3. Okay, so y is equal to 3 sine 2 times x is 3 pi over 4. minus pi over 2, which means 3 sine, no, 3 pi over 4 minus pi over 2 or 2 pi over 4 is pi over 4 times 2 is pi over 2. Sine of pi over 2 is 1. The answer is 3. So the second one would be 3 pi over 4, comma 3. So I got this pair for you. I got this pair for you. And I have 3 more to go. So I got this one, and now I have 3 more to go. So I showed you 2. You can do the rest of them, but let me quickly show you one more. So we did 3 pi over 4. Let's do pi. See how fast it goes. If I put pi here, everybody, if I put pi here, pi minus pi over 2 is pi over 2. Times 2 is pi. What is sine of pi? 0. 3 times 0 is 0. So the next one, again, I think I showed you. The next one, easily we can see. If we plug in pi, we get pi. So I showed you 3 points. Make sure for practice you do the 4th one and the 5th one. How do you practice? I mean, it's very simple. Just put 5 pi over 4 here. I hope you realize pi over 2 is like 2 pi over 4 and so forth, like pi over 2. So 5 pi over 4 minus pi over 2, and you can figure out what you get. You get 3 pi over 4 times 2, 6 pi over 4, 3 pi over 2, and that becomes negative 1 times 3 becomes negative 2. So we have those pairs. All you have to do, plot 5 pairs. So pi over 2, 0. 3 pi over 4, 3. Pi 0. 5 pi over 4, negative 3. 3 pi over 2, 0. And now connect. Connect. That's it. This is a complete cycle. And before we move on, again, notice because of the phase shift, see, it would be 0 from 0 to pi. Because of the shape, phase shift, it starts at pi over 2. And instead of pi, it ends at 3 pi over 2. See, starts here, ends here. Now you continue indefinitely on both sides, right? Because it's a periodic function. Let's do this one. And again, we are going to take out number 4. So we get 2 cosine 4 times x minus 3 pi over 4. So take out number 4. That's the first step. Now, to graph this, in order to repeat what we did in the previous one, we are going to ignore this class. We will figure this out at the end, So for now, completely forget it. Imagine it doesn't exist. Because after you're done with your work, what is the effect of -1? Up or down? It's down by 1 unit. So when you finish this, all you have to do, take it down by 1. So for now, we are going to completely ignore that. We are going to pay attention to this part. We're going to pay attention to this part only for now. It makes it easier. So A is 2. The period 2 pi divided by 4 gives us, because omega is 4, 2 pi over 4, which means pi over 2. Therefore, no phase shift, we would go from 0 to power 2. But this phase shift says go to the right by this much. And so we are going to move this to the right by this much. That means we're going to add to each part 3 power 4. And so a complete cycle starts from 3 power 4, ends at 5 power 4, and then we continue in that. So we have to cut this into 4 equal subintervals. To do so, we're going to cut the period into 4 parts. That means divide this number by 4, which gives us power 8. And so basically it means this, class. It means this is going to go to 3 power 4 to 5 power 4, okay. The next one would be 3 power 4 plus power 8, just as an example. That's the meaning of it, okay. So 3 power 4 plus pi over 8. 3 power 4 is 6 pi over 8. This is 7 pi over 8. The next one, I need to add to this one, pi over 8. And that's easy. It makes it 8 pi over 8. 8 pi over 8 is pi. The next one, I need to add pi over 8 to this one. And that's easy, makes it 9 pi over 8. And then when I add pi over 8, I get to that one. So here's the numbers. So again, a quick recap. Here's the beginning, here's the end. See, the beginning and the end, okay? In between, add pi over 8, you get 7 pi over 8. Add pi over 8, you get 8 pi over 8 or pi. Add pi over 8, you get 9 pi over 8. Now, from here to here, from here to here, here to here, here to here, are the 4 subintervals. A quick recap. First, we take out the 4. We say for now, we're going to ignore this. We have the amplitude and the period is 2 pi divided by 4. The period is power 2. No phase shift. We're going to go from 0 to power 2. But clearly there is a phase shift. So this will be moved to the right by the phase shift, which is 3 power 4. This interval will be cut into 4 subintervals. In doing so, this is the process. Divide the t by 4 and keep on adding until you get to the end. Now, all you have to do, plug in and evaluate. So, for example, I'm going to show you a couple of them. 3 pi over 4. Remember, we are not paying attention to that one. Although, you can plug it in, including the negative one, and in one shot, you have the answer. So 2 ways to do that. One is that you plug in, and you do include the negative one, and you have the proper answer for the last step. The other one is that you plug in, not paying attention to the negative one, and when you have that graph, you bring it down by 1 unit. Either way, it works. Okay. So if I plug in 3 pi over 4 here as the first one, this is 0. Okay. So we are going to include the one, so you see how that goes. Let me erase the mess. And let's say we are going to plug it into the entire one. So if I put 3 power 4, 3 power 4, that means y is 2 cosine of 4 times 3 power 4 minus 3 power 4. Again, I'm showing you all the details. And subtract 1. Now, this is obviously 0 times 4 is 0, 2 cosine 0 minus 1. You know cosine 0 is 1. 2 times that is 2. 2 minus 1 makes it 1, which means the very first pair has coordinates 3 power 4 and 1. Okay. Now, if we do not include this, then the first coordinate would be 3 power 4 and 2. Please understand, this is without the negative. Let's go to the second point, 7 power 8. Okay, so if I plug in 7 power 8 here, I get y is equal to 2 cosine 4 times 7 power 8 minus 3 power 4 minus 1. So 3 power 4 is 6 power 8. So this is power 8 times 4 is power 2. So this one is 2 cosine power 2 minus 1. You should know cosine of power 2 is 0. Therefore, the answer is negative 1. Therefore, we have 7 power 4 and negative 1 for this function. If we ignore that negative 1, the pair would be 7 power 8, comma, 0. Okay. Now the third one, let me show you, because I don't want to go through that. The third one is pi. If I put pi here, subtract 3 pi over 4. Remember, pi is 4 pi over 4. So minus 3 pi over 4 becomes pi over 4 times 4 becomes pi. Cosine of pi, negative 1 times 2, negative 2. And negative 1 is negative 3. Or don't include that. So let me erase, let me show you all those. And I'm going to assume you can find the rest of them, everybody. Okay, so I did this one for you, this one for you, this one. You can plug in 9 pi over 8. Remember, this is 6 pi over 8, just to give you an idea. And I hope you see that their difference is pi over 2, so that thing becomes you. So if you plot those pairs, and then you go indefinitely on both sides, you have the final answer. However, if you ignore the negative 1, okay, that means you add 1, everybody. If you add 1 here, so this is 2, add 1, this is 0, add 1, this is negative 2, add 1, this is 0, add 1, this is 2, you get those pairs. Again, ignoring that one, you get 3 power 4, 2, 7 power 8, 7 power 8, 0, you get pi negative 2, 9 pi 8, 0, 5 pi 4th, 2, and here's the graph. Again, you're not paying attention to this one. And you can move so this is one complete cycle. Go indefinitely on the left and right. That's the graph. Now, the effect of this, bring it down. So bring it down by how many units? So bring this down by 1 unit. And these are the answers that here, please understand, for example, the first one was 3 power 4, 1. The next one was 7 power 8, negative 1. The next one was pi -3, and so on. So very straightforward. I hope everybody's comfortable with that. All right, the reverse process. We want to build sinusoidal models from data, steps for fitting a sine function y equals a sine omega x minus 5 plus b to data. By the way, whether you put it into sine or cosine makes no difference. Normally they go with sine. Okay, and we start with the following. Determine A. A is the amplitude of the function. The largest data minus the smallest one over 2. So max minus mean over 2. Determine B, the vertical shift of the function, largest data plus smallest data divided by 2, max plus mean divided by 2. Determine omega. Since the period is t, the limit, the time it takes for the data to repeat is t equals 2 pi over omega. Now, if you do the cross product, omega is 2 pi over t. I hope you see that you can, interchange those two. So omega is 2 pi divided by t. Step 4, determine the horizontal shift of the function by using the period of the data. Divide the period into 4 subintervals of equal length. Determine the x-coordinate for the maximum of the sine function and the x-coordinate for the maximum value of the data. Use this information to determine the value of the phase shift phi over omega. I want to make sure we understand what's happening here. If you look at a sine function as an example, everybody, it looks like this. And the maximum occurs when you divide the period by what? So this is the first one, second, third. So you can see where the maximum is supposed to happen. Okay. There are 4 arcs, 1, 2, 3, 4. So it happens 1/4 of the way. So the difference between what the data shows and this one, that shows the phase shift to the left or right. That's the concept. I'll show you in a moment. Here's the summary, everybody. So to get this and taking the omega out, the amplitude is max minus mean divided by 2. Remember, for example, here, the amplitude, we know it to be 1. So max is 1, mean is -1, 1 minus -1 makes it 2 divided by 2. B is max plus mean divided by 2. So I want to make sure that you understand this is the B, which is y equal to 0. So 1 and -1, they add up to 0 divided by 2. Period is 2 pi over omega, and omega is 2 pi over t. So just making sure that we understand the basics and we are in good shape. All right, we are going to look at this example. Write the equation of a sine function such that the amplitude is 3, the period t is 3 pi, and phi over omega is -1/3. All right, let's figure out what we need to do. The amplitude is given. So we are looking at the formula here or here. and A is given. We know that omega, okay, so first, here's the formula, this one, right? We're going to use the formula that we have. All you have to do, class, what is A? Plug in. What is omega? Plug in. What is phi over omega plus? So this is given, this one. Basically, we need to find these two. To find these two, let's go with omega. Omega is 2 pi over t. And what is t? 3 pi. 2 pi over 3 pi is 2/3. So we have omega again. We have A, we have omega, we have phi over omega negative 1/3, which makes this positive. And there is no B because there's no information given. You don't have to worry about that. And just plug in 3 sine of a 2/3 x. Now, minus phi over omega, that means minus negative 1/3. It's important to understand that why it becomes positive, because it's minus negative 1/3, so plus 1/3. Okay, everybody? Now, we're done. But if we want to write it in this format, we have to distribute the 2/3. So this becomes 2/3 x, and this becomes 2 over 9. Again, depends whether they want it this way. Normally, they want it this way. So you have to distribute the 2/3. Otherwise, you don't have to do that. So this is the basic. There is no b involved, okay? That's a basic sine function. Example 5, draw a scatter plot and find a sinusoidal function of the form y equals a sine omega x minus 5 plus b that fits the monthly temperature data for Indianapolis. So that means scatter plot, that means plot those pairs. And how do you plot them? 1, comma 28.1, 2, comma 32.1, 3, comma 42.2, all the way to 12, comma 31.6. So again, just write the first one so you see. The first pair, for example, is 1, comma 28.1. Okay. April, for example, 4, comma 53, and so on and so forth. So you plot them looking like that, okay? All right, so A is max minus mean divided by 2. So where is the max? Here. Where is the mean? Here. Can we locate it precisely here so we know the numbers? So let me erase my work. So the maximum July 7th, 75.4, the minimum January 1st, 28.1. Look at those numbers, okay? This is where we get them. The largest number, the smallest number. So their difference divided by 2, 75.4 minus 28.1 is 47.3. Divided by 2, 23.65. So we got the A. So far, so good. B is easy. Add them up, divide by 2. Same numbers, add them up this time, and you get 103.5 divided by 2. you get 51.75. So we have A and B. Now, T is 2 pi over omega and is 12 months because we are dealing with a monthly temperature, okay? So cycle is regarding monthly temperature. There are 12 months. And so omega 2 pi over T, 2 pi over T. What is T? 12, making it pi over 6. All right. Now we have most everything. We need to find the phi, and to do so, let's look at the basic sine function to remind everybody that we have a 1, 2, 3, 4 arcs. And from 0 to 2 pi, we cut it into 4 equal parts. So T is 12, we cut it into 4 equal parts. The maximum occurs at pi over 2 comma 1, okay? 1/4 of the way, so 2 pi divided by 4 is pi over 2. So we are going to go with 0, 6, 12, and this is the maximum. So T equals 12, T divided by 4 is 3. So T is 12, we know that already, right? Divided by 3. Divide by 4, you get 3. Why do you do that? Again, pay attention to the basic one, compare it to the basic one. The basic one goes from 0 to 2 pi. Each arc, that means 1/4 of the way. The maximum occurs 1/4 of the way at pi over 2. In this case, 1/4 of 12 would be 3. So that would be when there is no phase shift. So if it happens somewhere else, the difference between the two would be the phase shift. The x coordinate of the maximum is for July, which is number 7 instead of 3. So if there is no phase shift, class, no phase shift, the maximum occurs at pi over 2 comma 1. In this case, would happen at 3 comma whatever the number that you have to calculate, right? 3 comma a, to be honest with you. Okay, but the absolute value of a. But it's not happening at 3, it's happening at 7. So that means from 3 to 7, it's been shifted by how many points? By 7 minus 3, or 4 points. So that means the phase shift is 7 minus 3 or 4. So now into this formula, we have phi over omega. A, 23.65. Omega, pi over 6. Phi over omega, 4. And B, 51.75. Now, if you want to make it look like that, you just have to move the pi over 2 in, and this becomes just change these to pi over 6x minus 2/3 pi. Okay, 2/3 is hard to see. Let me just erase it and do it again. So this becomes pi over 6x minus 4 pi over 6, 2 pi over 3. If you want to do that, that's just as good. All right. The number of hours, here's example 6, the number of hours of sunlight in a city. On the summer solstice, longest day is 15.3 hours. And on the winter solstice is the shortest, 9.08 hours. Find a sinusoidal function that fits the data, and in this form or in this form that we have seen. So we go through the process. We need to find the amplitude, which is A max minus mean divided by 2 max minus mean. 15.3 minus 9.08 divided by 2 is 3.11. The vertical shift or B, add them up, divide by 2. 15.3 plus 9.08 divided by 2 is 12.90. Now we're talking about the number of hours of sunlight in a city on a specific day or in some day. That means we have 365 days. That means the period is 365. So T is 2 pi over omega, and it's 365. T or 2 pi over omega is 365, which makes omega 2 pi over 365. I hope you see that you can interchange those. That's an elementary algebra. And so into this formula, if you will, we have A. So we put 3.11. We have omega 2 pi over 365. We have B is 12.19. And we just write phi over omega. Here's the reason we don't have the details for that. Note, the value of phi can be found if the day and the month is given for each case by subtracting 365 divided by 4 from the longest day. So if we know which day it is of the year, the day number so and so, we subtract it from that. Remember what we did in the previous page again. A basic cycle of a sinusoidal function. The maximum occurs t divided by 4. That's why this number. So if it's t divided by 4, there is no phase shift. If it's not t divided by 4, there is a phase shift. You look at the difference.